Okay, in this video, we're still on chapter P.3, the third section of the probability chapter. We're going to look at the mean of a random variable. Okay, so we have a formula here. The mean for a discrete random variable with the probability function p of x is given by this formula. So this right here is a Greek letter mu, spelled in English mu. So mu is equal to, again, summation. This means we're going to add a bunch of stuff together. X times px. So this x times p of x means we're going to take all the random variable values times their each respective probability, then add them together. Alright, so let's look at an example. This is data from AP statistics exams a couple years ago. So AP stats, you can get scores between 1 and 5. And looking right here, 23% get 1, 18% get 2, and 13% get 5. If I remember correctly, you get college credit getting above a 3. Could be wrong about that. Okay, so if we want to figure out, well, what was the average score of all the students who took the AP test? Well, this mu, again, that summation, is x times p of x. So in terms of this table, you multiply 1 times 0.23, multiply 2 times 0.18, as is happening right here, multiply 3 times 0.24, 4 times 0.22, 5 times 0.13, and then this summation symbol says add those numbers all together, throw them in your calculator, and we get the average score is a little less than 3, 2.84. Let's go over another example. Suppose we have a $1 lottery game and you know the prize amounts. You have a 0.3%, 0.003% chance of winning $55, about a 4% chance of winning $5, 21% chance of winning your money back, and a 74% or so chance of winning 0. So what would be the mean winnings for buying a ticket? So if you were to buy one ticket over and over and over again, this mean kind of means, mean or average means if you were to buy many, many, many tickets, what would you expect to win or lose per ticket? So that mean with that formula would be that mu, Greek letter mu, well, $55 times the small percentage. Multiply these two together, the $5 times the 0.043. Multiply the $1 times 0.213, and then 0, the zero's out, and 0 times the 74. Add all these numbers together, and the mean value, again, this means your mean winnings, if you're to buy one ticket over and over and over and over again, would be 59 cents. So the question is it worth $1 to play this game? Unless it's a charity you want to support, no. Because you spend $1, but you're only going to get 59 cents back. So on average, rounding this, you lose 40 cents for every $1 ticket you buy. Okay, so very quickly, take a look at this probability distribution table that we looked at before in the last video. Without doing calculations, we can compute this. What is likely to be close to the mean of this random variable? I think mean is kind of like the middle. One way to think about the middle, the most likely outcome. One thing to look at these options, we could cross off A and B. The mean has to be somewhere in the actual values, not the probabilities. The probabilities affect what the mean is going to be, but the mean should be somewhere between 10 and 50. But notice right here, 50 has a 40% chance of happening, and 40 has a 20% chance of happening, and then 30 has a 20%, and then 10 and 20 are least likely, only 10% chance of those happening. So the mean of this should probably be somewhere over here. So the values are between 10 and 50, but they're more weighted. They're more likely to be between 30, 40, and 50 with more emphasis on the 50. So probably, 40s or so. But we could actually compute the actual calculations. So how do you find the mean exactly? Multiply x times p of x. X times p of x, x times p of x, and so on. And then add them all together. So it's done right here. You sum up 10 times 0.1, 20 times 0.1, and so on, and get actually exactly 40. 40 is the exact mean of this probability function. Okay, so we're going to spend a lot more time in Chapter 2 talking about what variance and standard deviation actually mean. For right now, before we get into the formula, the basic idea of a variance and same with standard deviation, it's a way to measure the spread of your data, or in this case, the spread of your variable. How far spread is it? If all the data is very close and compact, closely together, then the variance, standard deviation are going to be close to 0. And if your data is very far and spread out, then your variance and standard deviation could get arbitrarily big. But right now, we'll just kind of go with the formulas, and like I said, we'll come back to Chapter 2 and talk about variance a lot more than standard deviation. But for probability functions, this is how you compute variance. Variance is this sigma, Greek letter sigma squared. And kind of multi-step process, is a little bit tedious. You take each random variable value, subtract the mean, square that, then multiply it times the probability of x, then add it all together. And to get the standard deviation, you just take the square root. As I said, I'm going to spend a lot more time talking about what the standard deviation means in Chapter 2. But for computing this, the AP Statistics exam scores, we computed a couple of slides ago, the average or mean is 2.84. So to find the standard deviation for these AP test scores, let's just look at this first set right here. I'm going to take 1, because 1 is the first x value, minus the mean, 2.84, then square it, then multiply it times the probability. So that's this first term, and then keep going. The second random variable value in the AP test score is getting a score of 2. So you take 2 minus 2.84, square it, and then multiply it times its probability, and so on, until you end up with the last value, 5 minus 2.84, square it, multiply it times the probability. Throw this in your calculator, you get 1.8144. This is variance right here. So the last step we have to do to get the standard deviation is to take the square root, 1.34. Alright, so I'm going to pause this, or take a break for about 10 seconds or so. You probably need more time to compute this by hand. Be good practice, so I suggest you pause your video and compute the standard deviation by hand, and with the calculator assistance, of course. Alright, if you're still computing, I suggest you pause your video. Let's see, they get 40. How did they get 40? So, a couple slides ago, we talked about the mean of this distribution to be 40. So looking at this formula, 10 minus 40 squared, that's from the first random variable value, x value, 10 minus 40 squared, times its probability. And then you do that the same for all 5 of these variable values. 50 minus 40 squared times 0.4. That is sigma squared. This is the variance. So then to take the square root of that, we get 140. Excuse me, the square root of 190 to get 13.78. Oh, I just noticed right here. Okay, so these values are for the mean. We talked about the mean before. So this is the mean. So I got to change this, but we have the standard deviation is this 13.784. All right, as a quick summary, random variables are just numerical outcomes from some random process. This could be almost anything. Probability function gives the probabilities for the possible values of a discrete random variable. And again, those probabilities have to add up to 1. So really the only definition for probability function. The mean for a discrete random variable is this mu equals summation of x times p of x. And standard deviation is given by this, I'd say, kind of cumbersome formula. It's not difficult, it's just kind of cumbersome to compute, but you'll have to practice some of that for homework. And here's a summary of section 5 or P.3.